Today we will learn about topic 4 is forces. 4.1 Basic of forces and free body diagram. Learning outcomes. At the end of this topic, students should be able to identify the forces acting on a body in different situations: weight, tension, normal force, friction, and external force. 4.1 Basic of forces and free body diagram. A force is something that is capable of changing an object's state of motion. A force is a push or pull upon an object resulting from the object interaction with other object. Is a vector quantity, meaning it must have magnitude and direction. The dimension of the force is given by F equal to ma equal to mlt power negative 2. SI unit of force is kilogram meter per second square or Newton. 4.1.1 Weight of a body is force acting on it due to gravitational pull. Formula: W equal to mg. M is a mass of body in kilogram. G is acceleration due to gravity. Unit is Newton. Direction is always directed downward, means it toward to the center of the earth. Weight, also known as gravitational force, varies slightly with altitude because weight depends on the strength of the gravity. The greater the distance from the earth, the less the strength of gravity, the less the weight a body has. Means weight on the earth's surface is greater than weight on a moon surface. Look at the picture on the right side. Which direction of its weight? The direction of its weight is towards downward. 4.1.2 Tension is the force in a cord that pulls on a body. It is always directed away from a body and along the cord. Unit is Newton. The cord has negligible mass, unbreakable, unstretchable, and frictionless. The tension pulls at either end of the attachment with the same magnitude. For example, string, chain, wire, cable. Look at the picture on the right side. Which direction of tension acted on the string? The direction of the tension acted on the string is toward downwards and upward. Magnitude for this tension is same, but its direction is opposite direction. 4.1.3 Normal reaction force. The force that exists whenever two solid surfaces are in contact. Direction always perpendicular to the surface that the object is in contact. Unit is Newton. Normal reaction force and not always has to be the same as weight. Look at the picture on the left side. The direction of normal force is upward because it is perpendicular to its plane. Look at the picture on the right side. Normal reaction force also perpendicular to the inclined plane. 4.1.4 Friction. The force that resists the motion of a body as it slides over the rough surface. Direction acts parallel to the surface in contact and in the opposite direction of the motion. Units Newton. There are two types of friction force. First is static friction. Second is kinetic friction. Look at the picture. If the ball moves toward to the right, so its friction is toward to the left. 4.1.4a Static friction force is force at the interface between two stationary surfaces which prevent the surface from sliding over each other. Formula: Fs equal to mu s times n. Mu s is coefficient of static friction and is normal reaction force. Frictional force that act on the object before it moves, different value for all material. Just before an object starts to slide, Fs is maximum. 4.1.4b Kinetic friction force Fk. The friction force that exists between two objects when there is relative motion at the interface of the surface in contact. Formula Fk equal to mu k times n. Mu k is coefficient of kinetic friction and is normal reaction force. Fk acts in the direction opposite to the direction of motion. Value of mu s and mu k depends on the nature of the surface in contact. Difference between static friction and kinetic friction. For static friction, the force of friction that exists between two solid surfaces that are non-moving or at rest only. But for kinetic friction, the force of friction between two moving solid surfaces in contact with each other. In general, mu s greater than mu k, so Fs greater than Fk. Factor affecting friction force. Type of surface in contact. Number 2 is how hard the surfaces are pressed together. This is table for value of mu k and mu s. Same material but different value of mu k and mu s. In general, mu s greater than mu k. Consider a block on a rough surface. An external force F is applied on the block if number 1 F less than Fs. The block won't moving. As F increases, Fs will also increase until it reaches its maximum value. When F equal to Fs, the block will start to move, which is called the point of slipping. Number 3. Once an object starts to move, the force of friction changes from static friction to kinetic friction. 4.1.5 External force is a force exerted on a system by an agency outside the system. Formula F equal to ma. M is a mass of object, A is acceleration. External force can either be push or pull force exerted on the object. The direction for external force is always directed outward from the body. Test yourself. Question number 1. What the answer? The answer is C. The frictional force on Q is greater than P. Question number 2. What the answer for this question? The answer is B. Fs equal to mu s times n.